So after covering the true-false, deciding if something is a parallelogram, finding missing values from lots of different quadrilaterals, and then finding the area of these shapes, your test is going to end with using coordinates to determine what a shape is, find its most precise name. So in example number 34, we're going to start by graphing these points D, E, F, and G, and our job is to determine what is the most precise name for this quadrilateral. So let's just start by graphing this. So negative 3, 1, 1, 2, 3, 1 is point D. E is negative 7, negative 3, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. 6, negative 3, 1, 2, 3, 4, 5, 6, 1, 2, 3. And then G is 2, 1. So just looking at this shape, right now I'm thinking that it is definitely a trapezoid. So I'm going to determine the most precise name for this quadrilateral. If I'm thinking it's a trapezoid, then I think of the properties that I know about it. To be a trapezoid, I have to have exactly one set of parallel sides. So I'm going to look at side DG, and I'm going to try and determine if it is parallel to EF. Now this example is pretty simple because this is a horizontal line with a slope of 0. So the slope of DG equals 0. And EF is also a horizontal line, so the slope of EF is also 0. So since the slopes are the same, the lines are parallel. Very important concept you need going into this test. So that proves to me that I have one set of parallel sides. And I can tell that DE and GF, if I were just to extend those, are going to run into each other right here. So ED and GF are definitely not parallel. So this tells me it's a trapezoid. It's not a kite because I don't get any parallel lines in a kite, and it's not a parallelogram, rectangle, rhombus, or square because I don't have two sets of parallel sides. But precise, that means the most specific name that I can give this shape. Well, trapezoid is good, but we also have isosceles trapezoid. So I have to decide, is this an isosceles trapezoid? And the only way to do that is to check if DE and GF are the same. So I'm going to have to find some distances here. So I'm simply going to do a distance formula. And my suggestion to you, instead of remembering the distance formula, is to create right triangles. So point D is up here at negative 3, 1. I'm going down to 1, 2, 3, 4. So that's a distance of 4. And I'm going over 1, 2, 3, 4 again. So DE is going to be a Pythagorean theorem of 4 squared plus 4 squared. And then we'll have to square root that to find the actual distance. So it's going to be 16 plus 16, which is 32, and the square root of 32 is going to reduce to 4 root 2. So now I got to check and see if that's exactly the same as GF. Again, I like drawing the triangles, but if you like the distance formula, here's a quick review for you. Since we're looking at G and F, I'm going to take the x minus the x, so 6 minus 2. That'll tell me the distance between their x's. I'm going to take the y minus the y, so negative 3 minus 1. These two values are the same thing I got when I counted down and over for DE. But it's x minus x squared plus y minus y squared, and then we square root the whole thing. So here I'm going to get 6 minus 2 is 4. 4 squared is 16. Negative 3 minus 1 is negative 4. But negative 4 squared is also a positive 16. So you can tell probably right now that I'm going to get the same number because I'm still going to get the square root of 32, which is going to reduce to 4 root 2 for GF. So DE and GF, in fact, are the same. So if I have a trapezoid that has two legs that are congruent, a more precise name would be isosceles trapezoid. And that's as specific as a trapezoid gets, because if it's isosceles, my diagonals will be congruent, and my base angles will be congruent, and I have more properties to know about this shape just because I know it's isosceles. So that's what I'm looking for when you do these coordinate problems. Now in your test, you're going to have to give me the most precise name. You're also going to have to find the area. So let's go ahead and find that, even though this problem doesn't say that, because you'll need to do that on your test. Once you've determined what it is, you use the formula for that shape. And since it's a trapezoid, it's going to be 1/2 the first base plus the second base multiplied by the height. So I need to find the distances of the bases, which would be DG and EF. Well, you can just count these because they're perfectly horizontal lines. They're not at a slant like GF and DE. So from D to G is 1, 2, 3, 4, 5. So base 1 is going to be 5. Plus base 2, which is going to be, make sure I count this correctly, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now, when I draw a really rough sketch like this, I don't trust myself with my counting. You guys know me, I don't count all that well. So I'm going to go and double check on E and F. So E and F, they're both at -3. So I'm going from -7 to 6. -7 minus 6 is a -13. So yeah, it is a total distance of 13. I counted that correctly. So my height has to go from the top base to the bottom base at a right angle. I already counted that one. That one was 4. So my height is 4. So I'm going to find the area of this trapezoid by saying it's 1/2 the sum of the bases, which would be 5 plus 13, for a total of 18, times 4, which equals 36, when I multiply all that out. So there's my most precise name, there's the area of the shape using the area formulas that I know, and there's the graph. These are the 3 sections of that question that you're going to have to answer on your test.